Okay, hello. What, Tuesday? Tuesday. So don't forget that you want to make sure that you save it to Google Drive. I already did because this is my second take, so it already has it. And click join lesson. The Nearpods will be graded now. So there's a quiz embedded. You need to make sure that you take your notes. So I'm grading over what you got on the quiz and did you write in your notes? Okay. All right, so we're on Unit 4. Unit 4 is going to be about can you identify if a situation is linear and about answering questions given that information once you made the assumption that it is linear. Okay, so let's get started. All right, here's our weekly objective. So for this week, students will know how to identify a situation, to identify if a situation can model a linear function. Students will understand the difference in the meanings of the x and the y-intercepts for a given situation, and students will be able to write the linear function of a given situation in slope-intercept form. All right, linear model. If there's any way I can get this. All right, there it goes. All right, so a linear model is an equation that describes a relationship between two quantities that shows a constant rate. So right here, I tried to show you how this right here is showing a constant rate. So it has to be going up or it can be going down. But there's no like curves in it. There's no U shapes. There's no L shape. It's just going straight in a constant rate. Okay. All right. So by looking at this picture, we can go over here and be like, hey, this is going in a constant. Oh, don't forget, we gotta go over here and make this a little less. So we weren't that big. Is also a constant because it's also increasing at a constant rate. Okay, so this is also linear. Okay. Another thing that we should be able to know is to identify that the y-intercept is right here on the y-axis. Okay, we should know that much. Why is it not letting me write? Okay. All right, so we got the constant on that. Well, I mean, we identified that it was linear. The table showed the amount of grain in a silo after X days. So remember, this is kind of like a cylinder with the funnel at the top. So this is where they put the grain. All right. So all we're trying to figure out is if it's linear. So what you want to do is to figure out what the pattern is. What's the pattern in the Y's? What's the pattern in the X's? And to see if that's going to give you a linear or not. So we're going to zoom this out a little bit. All right. So right here, the pattern is what? Did it go up? Did it go down? It went down, so we'll put negative right there. But we need to figure out how much did it go down by. So we would get a calculator and we would figure that out. Okay, let's see, let me get a calculator real quick. You can use your phones, which is basically what I'm using right now, to figure out. All right, let's see. What is it? Sorry. Calculator is not coming up. Okay. So we're going to do 1190 because that's first. 11900 minus 13400. Why did I do the 1190 first? Because it's always the second minus the first one. Remember, the slope form is y2 minus y1 over x2 minus x1. So we have to do the second one first. That came out to be negative 1500. Okay, then we do these two. 22 minus 10, that's 12. Okay. We look at this pattern, do this one. This one's going to be 626. Let me do these first because those are going to be a little bit easier for me to do. 16. All right, let's do this one. 8650 minus 11,900. That's negative 3,250. And then over here, it's 6,650 minus 8,650. That's negative 2,000. All right, so to us, we figured out what the pattern was, but we don't see that it's constant on either side. The y's have different ones, the x have different ones. So what I have to do is I have to do the ratio. I have to figure out, is the ratio going to be constant? Okay, so ratio means that you divide. You're going to always do the y divided by the x. So for the first one, we're going to get the negative 1,500 divided by 12. I get negative 125. For the second one, I'm going to do negative 3,250 divided by 26. I get negative 125. All right, for the third one, I'm going to do the third set we have, which is 2,000 divided by 16, which is negative 125. All right, so this is linear because they all have the same constant. They all have the same constant ratio, so it is linear. All right, let's look at this problem over here. Let me move my face a little bit. So John has saved $125 for spending money to use on a trip. His part-time job pays him $15.50 per hour. He plans to use all the money he earns from the part-time job as spending money for his trip. If he works X hours at his part-time job and his trip is 5 days long, what linear function can be used to determine? They already told us linear function, and we also know that there's only one rate. The rate is not talking about area. It's not talking about anything that has to be doubled every day, anything. It's just talking about he's going to get this every hour. It's a constant rate of change. Okay? So this is also linear. Okay, we go to the next one. This color should just be different. And zoom this out. All right, so we move this again. A manufacturing company is purchasing safety goggles for its workers. The first 150 pairs of safety goggles will cost $337.50. Each additional pair of safety goggles costs $250. So just for every one pair, you're going to get this. Again, it tells you linear function. So yeah, this is going to be linear. So you're looking for keywords. Sometimes they already tell you in the problem, like the other ones, but you're also looking for a constant rate of change that's only going to change per one. Okay. So here's the graph has to be a line like we looked in the first picture. A constant rate is you find the ratios of the patterns in y and x. Remember, the ratio is always y divided by x. And then is it a word problem? Then the constant rate, look for the keywords like per, each, and every. Okay. And sometimes they'll help you to write the equation. And then when you write the equation, you'll see, like, let's try this one. Y equals, they're paying 300, that's an ugly 337.50, plus they're going to get 210 for each pair, but each pair after the 150. Okay, so notice there's only one x. The exponent for the x is a 1. So an exponent of 1 will mean that this is linear. Right? And I forgot, and this is something that you have to do, is to always go back and make sure that you submit. Because if you submit, that says that it saves it. So when I get to see it, it'll show me that you wrote in it. Okay, I'm going to stop the video here because this is your quiz. I just want to go over the first one. All you're doing is clicking on the image, reading it, and determining, is this going to be linear? Write the equation if you have to, okay? And make sure that the exponent for the x is a 1. There's 5 questions. I'll start the next video after this.